Hello, my name is Felix Sotres. I am a student at the University of Illinois at Chicago. This is my video presentation for my Art 150 project, and it is a Spirobot. It's a little autonomous robot that is able to draw patterns with two different markers for two different colors. It's based off a random seed. The standard Arduino Uno board was used, and as well as the standard Arduino Uno software for it. Everything was done from scratch, so let's take a look. These were my main tools. A soldering gun. I got this one at Radio Shack. Really happy with it. It's got two main settings, a 15 watt and a 30 watt if you need more power. Really happy with it. Some heavy duty wire cutters, needle nose pliers, standard Phillips screwdriver, and a pair of scissors. Not much, but this is all I needed. Going to take a look at some of the techniques made for the Spirobot. Looking at the top here, first thing to note is that the shell of this is just really soft plastic, so I was able to take advantage of that by just using a drill. Here is the main control panel of it, a push button, two LEDs. The green one signifies movement, the yellow one signifies a ready state. Meaning that it's waiting for a push of a button so that it can actually go and draw its pattern. Once the push button is clicked, then the yellow LED will blink, giving the user about 2 seconds to step back so that the robot can do its thing. Each little leg of the push button as well as the LEDs has its own hole. This was done so that you could keep them separate and apart, and for the wiring on the inside. On the front of this, I drilled another hole on it. The base of it is just wood, so I was able to do that really easily. This is held by a zip tie, which actually worked out really well. It allows the body to be open and close on the front, so that was really nice. On the back of it, there's a servo holding the markers, which it will draw with. Again, that's screwed into the base of the unit. At the bottom is another wheel for support so that the weight isn't just on the marker itself when it's drawing, when it's in the downward position. And that's also held by a zip tie. The wheels on the side, those were off a toy. They spun around by themselves. I had to use a rubber band here to make them stop spinning on their own. It also preserved the wheels so that I can just take this out and use it for future projects. Rubber bands on this were for traction for it, and we'll take a look at the inside. Here's the Spirobot opened up on the inside. You can tell really quick that it's opened up from the front. That zip tie is holding it together. The wiring from the inside, wire management is done through electrical tape. You can tell here the separate holes for the two LEDs, and then the push button right there. Each one has its own little hole for the pin. The Arduino board was used for it. It actually had power through an external power supply here on the battery. This battery was powering the Arduino, and the Arduino was powering the LED lights on this side of the breadboard, and one of the servo motors. The back side of the breadboard is powered by its own power supply here, and it powers the servo for the marker and the servo for the other wheel, the right side wheel. That was just to make sure that everything had enough power for it. The servos for the wheels are held into the wooden frame via zip ties. It was a really nice, elegant, simple, affordable solution. I don't have a big budget, so that worked out really nice. The wheels are attached directly to the servo attachment here from the inside, taking advantage of that soft plastic again. Here's one of the wheels so you can take a look. And one of the things I had to do for the wires is some of the wires are really soft, like the battery leads here. Those wires were really soft and they were hard to keep attached to the pins on the Arduino. So I soldered them together and covered them up with some electrical tape to wires that had a thicker, stronger wire. That made it really easy for hooking in and taking out. I did that as well. Here's a really good example of one, because the wire is really thin here, but soldered onto that makes it really easy for in and out. Well, there's a delay. There shouldn't be this long of a delay. There you go.